Okay, so I'm going to provide just one more example here for 8.2 large sample test for a population mean. And the example here reads, it's hoped that a new pain reliever will more quickly produce perceptible reduction in pain than a standard pain reliever. So the standard pain reliever, it takes 3.5 minutes on average. That's the mean to relieve pain, and the standard deviation is 2.1. So we have this new pain reliever, and we're gonna and we have a sample that we took, 30 sample size, which is a large selection. We have a sample mean of 3.1 minutes, and we have a standard deviation of 1.5 minutes. That would be a sample standard deviation 1.5. We do not have the population standard deviation. So it's unknown, and we are evaluating it at a 5% level of significance. Okay, so in order to do this, we need to follow our 5-step procedure to calculate. And the big question that we have is, does the new pain reliever relieve more quickly? So as a step number one, first thing we need to do is define our hypothesis. So the null hypothesis here is that the mean is equal to 3.5, okay? And the alternative hypothesis here is that the mean is actually less than 3.5 at a 5% significance, right? So alpha is 0.05, okay? And so steps 2 and 3 are kind of locked into one here. This would be step 1, I'm sorry. So we got steps 2 and 3. And basically steps 2 and 3 say, we need to say that the sample, right, it is large. But the population standard deviation is unknown. Okay, is unknown. And now we can calculate the z-score. So this would be, step 3 right here. And basically the z-scores, we use our formula. So we're going to use the sample mean minus the mean divided by the standard deviation over the square root of n. Okay, and to calculate this, we're going to do 3.1, because that is our sample mean, minus the mean provided here, which is 3.5, and we're going to divide it by 1.5 over the square root of 30. Okay, 30 being our sample size. And now when we calculate that, we should get negative 1.886. Okay. Now step number 4 here, so this is our 5-step procedure. We can say, since we're going less than, that the the alternative hypothesis is less than, and therefore it is left-tailed. Okay, it is left-tailed. And so what does that mean? So maybe I can draw a little picture. I'm going to move it down right now, but maybe you can draw a tiny little picture over here to the right to show what that means. But essentially what we're talking about here is that if we have a standard, we have a bell curve right here, and we're saying it's less than, okay, what we're saying is that we're talking about this value right here. So we could call this negative 1.8, okay, and we're actually talking about, this is left-tailed right over here down in this region, okay. So now we can go ahead and we can say that the critical values, so the critical value And since we are going to the left, we can say, negative z sub alpha is going to equal negative z sub 0.05, because that is alpha. And if we were to go ahead and calculate that and figure that out, we would actually get negative 1.645. And this is when we're looking at our standard normal table, all right, which is on my courses. Now we need to go ahead and we can create an interval here, and since this is how it looks, it's left-tailed, we can essentially say that we're going off to negative infinity on the left, but on the right we're actually stopping at somewhere, and it's stopping at negative 1.645. Okay, and 1.645 actually falls like right here, doesn't it? Okay, and so since it falls right there, we can now make our conclusion. And we can say this. We can say solution that since this falls within this region, like we're showing right here, then we can say that we can reject, okay, so first let me say falls in region, and therefore we can reject the null hypothesis and accept the alternative hypothesis. Okay? Okay, now likewise, we want to take a look at, a small sample unknown, and this kind of moves to 884. So essentially, if the standard deviation is known, then we are dealing with a z-score, which is what we were doing before with the large sample known or unknown. Okay. Now the big difference here is this one right here. If the standard deviation is unknown, just like we were before, and it is small, we are dealing with a critical values of t table. All right, so this is a t-score that we're dealing with here. So one thing I do want to do is just review the rejection regions, and we have these single-tailed tests. If our mean is less than, all right, then we're going to be rejecting down here in the lower region, right? If it's greater than, then we're rejecting up here, and we would say I didn't write this down, but if it's not equal to, okay, so if HA and we have the mean is not equal to, okay, the mean of the null hypothesis, then we can say that it's either in here or here, which would mean that we would reject it then as well in these regions. Okay. Now I'm going to go over an example problem with you that's going to talk about the standard deviation being unknown and small. And the example that I want to work off of, I apologize for giving you some seasickness right now, but we're going to put it right here. It has to do with a price of an item. So let's say that tennis racket price on average is $179. Okay. Okay. It is on average $179. Okay. And you bought a number of tennis rackets at an online auction site. And let's say you went at that online auction site, we'll call it Amazon or whatever we want to. We were able to find tennis rackets for 155, 179, 175, 161. So this is just a random selection right there. But basically, we want to test this a little bit. So assume auction prices are normally distributed, and there is evidence in the sample at a 5% level of significance to conclude that the average price of a tennis racket is less than $179 when purchased online. Okay, so what we'll do here is, this is our two-step problem. We're going to say that our null hypothesis is that the average price the mean price for tennis rackets is equal to $179. And we're going to say our alternative hypothesis is that the mean tennis racket price is going to be less than $179 if we're shopping online. And what we want to observe this at is a 5% level of significance. So therefore, alpha is going to equal 0.05 here. Okay. So number two, what we need to do is we first need to figure out, well, what type of sample are we dealing with? We know we're dealing with small. I forgot how to spell small, and it's small because how many values are we looking at here? We only have, I wrote 4 there, but we'll put one more in there, 8, 4. Okay. But we have 5 values that we're looking at, and I just threw these random values down, but we'll say we'll have 5 values because n equals 5, okay? And the population standard deviation is unknown. So with that being said, so we could say unknown. That means that we are going to calculate t, right? So 3 would be t is going to equal x minus, okay, the sample mean divided by the standard deviation over the square root of n. So therefore, our value of t is going to equal 169 minus 179. Did I write this down wrong? I think I may have written this down wrong. Screw that, I'll have to start over again.